Hello, today I'll be going over my NAND gate design that I built within Buildermint. If you don't know what a NAND gate is, it is a basic logic gate where you have two inputs and an output, and the output is high if there are no inputs or if only one input is on, and it is low if there is both inputs on. And in this design I have it so that an input high is if these lines are full, or an input low if there's no travel going through it. So, just to showcase this is when both states are off, and then we have both outputs being on. I'll get into why there are two outputs later, but for purposes, these should be identical and always will be. So let's showcase what happens when both states are on. And while we're waiting for it to transition, I just want to showcase something I built recently, and I showed this off in one of my other videos, but I built a 4-bit adder. As you can see right now, it's currently processing a 11 plus 13, but more or less I created some full adders out of these NAND gates using 8 NAND gates, and what this allows me to do, and at least here's that first one, is add two 1-bit numbers together and create a sum. So in this case I am adding in this case 1 plus 1. I do have these inverted, but here are the outputs. So this is A and this is B, and the output, if we go over here, in this case we're adding 1 plus 1, and again this is an inverted as well from that bar. So this means we have a sum of 0 and a carry out of 1. This one is not inverted. The reason I have these inverted is due to my display here. So it takes a high signal and turns it into a 0 as shown here. So that's why the inversion. But more or less we have 1 plus 1 equals 1, 0. And I've duplicated this 4 times to create a 4-bit adder. Okay. Now going back to the NAND gate, as we can see, when both inputs are on, we have a signal coming here, and what that does is it cuts off the signal here. So eventually these will empty. See, this one turned off, this one turned off. I do not have enough storages here, but let's place those back down. And we'll place these ones back down too. But as you can see, there's no input signal going in. Or no output signal, I mean. And then what happens when we remove one of these, we'll eventually get the signal to turn back on. Now, how does this work? I've split this into 3 separate components to showcase what's going on here. So the first step is an AND gate, surprisingly. And this is done through what is shown here. So what we have is a splitter here. So this is a 2 input, 2 output splitter. So if only one belt is on, what ends up happening is each gets split into a line that has 240 items per minute going through them. And these robot arms are configured to take 240 items off the belt. So what happens when I only have one on? Well, what happens is all these robot arms are able to capture a majority of the plates going into the system. Now, some do end up leaking through, but that isn't a problem with the next stage. And then moving on to the next example here. This one got full as well. But what happens when both are on? Well, they get split, but each of these lines becomes full because it's taking a half from A and a half from B and combining them, so we get a full. So what happens here is that these robot arms take half the plates on the line, but they recombine into a full signal. Now this is an AND gate as is. One problem is that is something called fan out, where only one input can be turned on through this output. So if I wanted to take this signal and plug it into another NAND gate, I could only funnel one input. So that's a problem. We need a higher fan out. We can't just have one AND gate connected to multiple circuits and create anything out of that. It would just be a straight line. So we need to add fan out to it, and that's what these next few stages are. So this next stage is a buffer, and it also uses a loop of filler item. So this works with any item as long as it isn't what your signal is made out of. So it'll take the output of this first section, as shown by the pumpkin, and it will take it, and what ends up happening here is that if the signal is high, we get a long loop of filler item. But if the signal is off, as shown here, we get a short loop. And how this works is that these robot arms are trying to hand it off to the robot arms down below, and they're both set to the same filter here, but it can't place it due to this full line. So this effectively creates a buffer where I'm converting one input into one output of the same level. Now, we can't really use this signal for any other NAND gates, right? Because this is a full loop. It only funnels to itself, and it is a different material. So the third stage of this design is more or less the same thing, but going instead from plates to frames is going back from frames to plates. So here's an example of it where we have that same loop as shown by the crates, where we have a line here that is blocked by the frames. And one interesting thing that is necessary is we need a power line, or what I like to call VCC, as a lot of this can be extrapolated into a circuit's perspective. So we need a line that always supplies plates. Now, and we also need, in some cases, a line that sinks plates, so that is always free to add more plates to. And I call that my VDD line, as shown by these Birch trees. But for this to work, we don't really need that too much. So what ends up happening? Well, I need to turn this on. Well, this will freely let things pass when there isn't anything in the loop, as shown in that previous example. So nothing's blocking them. And yeah, that's the main 3 steps. So what ends up happening is that this becomes our new output line, and this is infinitely expandable. All we need to do is increase this loop distance and increase the number of VCC lines, and we can have an infinite amount of fan out. So that allows us to power multiple other AND gate inputs. And going back to our other example here, it's still taking a while, but there are some quirks to the system that took multiple designs. So one thing that confuses a lot of people is, why are these robot arms and storages here? Isn't this slowing down your signal? Why do you need it if you want a full line as your output anyway? Well, one problem I ran into was input current on other NAND gates. So what ended up happening was, if we go back to this example, these plates do not traverse at the full rate of the belt speed. So normally that would be 480 items per second. However, because I have some splitters and recombiners here, it slows down the belt ever so slightly. So that ends up creating backup all throughout these input lines. So in order to prevent that, I have to have a overflow valve here, and I just made this with 2 robot arms where they cycle the items if there's room in this bottom one. So if this bottom one gets full, it'll go and send it to that plate sink, as I mentioned earlier. So that is the basics of my NAND gate, and this can be changed into an AND gate. It can be changed probably into an OR gate, and other systems as well. But NAND gate in this case is one of the most important, as it allows for complex circuitry. And in my general system, I do have a large VCC line which supplies all these plates, using robot arms that filter them down, and make sure that all these lines are always full. And then I also have a current sink, because we need to get rid of these inputs, because we do end up distorting the signal, so they can't really be used again. So we have to have lines that take in these inputs and send them back away. And that's what this system is for. So this takes these lines and makes sure that these storages can always be emptied. And then what's convenient is this creates a voltage source where I can feed this back in through into a full loop. And overall, that creates the NAND gate, and more or less you can do computational logic. I plan to create new designs in the future for ORs, XORs, and compact a few of these circuits down. But overall, this is the first of that I've seen of a NAND gate, and I wanted to share it with the community and hope you find some interesting purposes for this as well. Thank you.